What's up, my friend? I hope you are all doing well. So in this video we are going to see how we can implement our own cp command in C, right? But before diving into the code, let's see the behavior of this command. So basically the cp command is just copy the data from a file to another file, basically from the source to the destination. For example, we have touch, for example file 1 and file 2. Alright, both of them are empty. So for example, let's say vim file 1, and for example let's say hello world like this. Alright, and let's close the file and let's do clear. Alright, so let's do cut the file 1, cut file 1. It's contained the hello world message, and the file 2 is empty. And if we did the cp command and the file 1, which is the destination, sorry, the source, and the file 2, which is what, which is the destination, it will copy the data from file 1 until the file 2. So if we did cut file 2, we have hello world. This is the first case. For example, let's say we don't have the file 2. For example, let's remove it, and we did cp file 1 and file e. For example, if we did cut file e, we will found hello world. Alright, so basically here the cp command, it check if this file is here or not. If yes, it's write directly to it. If not, it will create the file with the same name and copy data from this file 1 to this file. Alright, so in cp we have a bunch of flags. I'm gonna implement two of them, which is dash e, dash e and dash v. Alright, so let's see the first flag. For example, let's do cp and dash e and file 1 and file 2. So it will ask me, do you want to override the second file, which is destination? I'm gonna say yes. Alright, and if I did no, it will cancel this operation. Alright, then we have the cp and dash v, which stand for verbs, which just say, or it declare that the operation have been done successfully. As you can see, file 1 copy to file 2. That's it. Alright, so let's get started. I'm gonna close this, or let's make it like this. Let's close it. I'm gonna include my important header files. I'm gonna include my header files. So we have here include, and we have here studio.h, sorry, h like this. I'm gonna include also, I need the unit cd.h like this, and we have also include, and we have I need the fstat.h for the flags for the open syscall, and we need also what, I guess this is state. So sys state, sys slash state like this dot h. Alright, and I'm gonna need the string header file, string header file like this. So string.h. Alright, so I need my int main, so we're going to do int main like this, int main, and we have int ac char pointer av, the argument vector. Alright, so I need a bunch of variables. So as we said, we are going to implement two flags. The first flag is the I flag, and the second flag is the V flag. Alright, so we have here the int I flag, as we used to do, will equal in the first case to 0, and here we have int V flag will equal to 0, and here we need the I, so int I will equal to 1, because we need to skip the name of the program because we are going to take input from the user. And here int the source file descriptor, source fd, equal to 0, or let's make it like this. And here int dest file descriptor like this. That's it. Alright, so first thing I need to do, check flags. A function that will check the flags. I'm gonna pass to it the av, the argument vector, and the address. Where is the address? And the address of the v flag like this, and here the address of the I flag like this. Why I need to pass this addresses? Because I need to change directly the value in this function, not just change it in the function check flag. No, I want to get the address of this variable from this function right here and change the value of this variable in the int main. Alright, so this function will return an int, so here int and check flag. Alright, and here I'm gonna do like open the brackets like this, and here I need to set my parameters. So here a v, and here we have int a pointer to the v flag. Yep, v flag, and here I pointer to the I flag. Good. Here I said that it will return a variables. Yep, it will return where we are pointing at, because here we are going to loop using the I. So for example, if we have two flags dash I and dash V, we need to skip two elements. So the indicator, which is the I variable, will increase in this loop, and we are going to return this increase in this I variable. Alright, that's it. So let's increase, for example, in G equal to 0 to loop, and we are going to do while G++, and while the AV of index G does not equal the null. Alright, like this, and we are going just to do a if condition and else if condition, and also the else. Good. Alright, so here I'm gonna do str comparison, so str cmp and the AV of index G like this. I'm gonna compare it with the dash I, for example. Is it equal to 0, which means they are identical? Then I'm gonna take the pointer of the I flag and I'm gonna make it equal to 1 like this. Alright, and I'm gonna copy this if condition, and here I'm gonna change dash e with dash v, and I'm gonna take the v flag equal to 1, and here else just I'm gonna break. Alright, good. Let's remove the spaces, and here I'm gonna do return G like this. Good. Alright, like this. Alright, so here we checked if we have the v flag or the I flag. We can do a check. For example, let's do printf, and here %d, and here let's do, for example, v flag v equal, and here I equal to %d also, and here let's print, for example, in the first case let's print the free flag v flag like this, and here we're going to print the I flag, right? And let's close this. Alright, so now I need to compile, so let's open our terminal. So we're going to do gcc, and we're going to do main.c like this, so we have no errors. So dot slash is out, and the v flag is equal to 0 and the I flag is equal to 0. And for example, if we did dash I, the dash I is equal to what? To 0. Why? What? We have a problem. We have a problem. Yep. There's the problem. So here, there's the problem. I said G is equal to 0. So here he's looping in the AV of index G, and he's going inside this if condition is equal to false, and here when these two are false, it will go to the else and it's gonna break, because here he is comparing the name of the program and we need to skip the name of the program. So we are going to do one here, and let's compile again gcc main.c, and let's do it out like this. So here it's 0 dash I is equal to 1. Good. And let's add also dash v, is equal also to 1. Good. Alright, let's continue and let's close this terminal like this. So everything's working well. Let's continue. So now we check the flag. Now I need to open this file, the first file. But first I want to do a check. I'm gonna check if this file that he is entering, is it a file or directory. For example, he can do like this, file, and insert to me a folder, and it's gonna be an error. Alright, I'm gonna try to open a folder and copy it to a file. So I need to do some checks to check if this is a file or a folder, and to do this I'm gonna use the fstat function. So this fstat function, I just need to pass with the path of the file or the folder of anything was this, and it's gonna give me all the information about this file or this folder. And by some macros and by some macros I can check if this is a file or a folder. Alright, good. So I'm gonna do struct like this, state, and st, for example. Alright, and here I'm gonna call my function, which is fstate. So fstate like this, and it need what? It need the file descriptor. Yep. So what I need to do, I need to open the source. So I'm gonna do like source file descriptor. Yep, I guess there is a problem. Why there is a problem? Struct. Yep, struct like this. Right, sorry, struct. And here this is saying, and here what is the problem? Yep, I need just semicolon like this. Alright, so first I need to open the file. So I need to pass the av of index I like this, and the flags or read only like this. Alright, and close. So here I'm gonna pass the source file descriptor. So if we see the parameter that this is static, we're going to see that it takes the file descriptor and it takes a pointer to the struct state, which we created right here. Alright, so we're going to pass the address of st like this. Good. Let's do a comment here. So let's say checking for the flags. Good. Declaring the struct to save to get the infos about the file slash folder. Alright, because we don't know yet. Here let's say opening the source file. Alright, and here let's say calling the fstate function like this. Good. Alright, function like this. Good. And here there is a problem. Address of st, declare start, get info, experiment must have internal. Yep, I need here a comma like this. Alright. So now I'm gonna do a check. So I'm gonna do if, and here I need to do is director. So here we have a like macros in this header file, which is sysstate, which contain a lot of macros. So one of them is director. So here we can just like pass the is director, and we are going to pass the st.stmode like this. So this is an element in the struct that check like the type of this or the mode of this file. This is a file or directory or a symbolic link or anything. Alright, so then we're going to do, if it's equal, is it true, then we're going to do printf, and let's say like this, let's say sorry, this is a folder. This is a folder like this, and return 1. Good. Alright, so let's open the terminal like this and let's check. So we're going to do gcc and main.c. We have no problem. And let's run it. For example, let's say I need to create a folder. So let's do mkdir folder, for example. And here's our folder as we can see. And we are going to run a.out and the folder. So here he will say, sorry, this is a folder. Alright, good. Let's close this terminal and let's continue. For example, let's say this is not a folder. Good. Now we're going to pass if we have the I flag. So if we have the I flag, we need to ask the user if he wants really to continue to open the next file and copy in data. Alright, so we're going to do here an if condition. So we're going to do if the I flag is equal to 1, we are going to do printf, right? And we are going to do like this. Do you wanna do you want to overwrite this file, right? So and let's say percentage s and the av of index I plus 1. So here iv of index I is equal to the first file, which is the source file. So iv of I plus 1 will equal to the destination file. Good, good. And here we are going to do a new line like this. So new line, new line, and we are going to do here a scanf, and we are going to do percentage s like this, and here we need an input, so we're going to create a buffer. Let's say input like this, an array where we're going to store the result of the user. So it's gonna be char input. It's gonna take, for example, 2 elements like this. Alright, good. So if the input of index 0, let's say for example, if it's equal to yes, yep, if it's equal to yes, then the character yes like this, then we need to do, or yeah, wait, let's say for example does not equal to yes. So does not equal to yes, then we're going to print a message where we're going to say this operation have been cancelled like this, 2 points like this, and sad face like this, and let's remove this. Good. And we're going to do return 1, return 0 because it's successful. Alright, now what we need to do, we need to open the next file. So here let's do a comment. So here we have checking implementing, let's say implementing the I flag. Alright, good. And here let's say checking, is this a directory? Alright, good. Opening the second file. Good. And let's go up here and let's take the test file descriptor equal to open, and like this, av of index I plus 1 as we said. Alright, then here the flags, or read and write, I guess, write and read only. And here we need O and create, so it's create, and here O and trunk. Then here we need to pass the permission, like here we are going to create a file, it needs a permission. Here we need to take the permission from the first file that we create right here, that we opened and that we opened right here, which is the source of file descriptor, and we need to get the permission from this function, which is fstate, and put it right here in the permission parameter for this open function. All right, so we're going to create a variable with type mode dash t equal to mode will equal basically to 0 in the first. Then this mode will equal here, let's go up down here, sorry, mode will equal to the st dot mode st mode like this, and we're going to do the add operation with this flag 0777. So this 077, it look like it will because we have this st mode have a, it's like a binary, it have a bunch of information about this file, the permission is the file or directory. We need to like delete all the information about is a file or a directory and just get the permissions of this file, all right, by this mask, right? Then now the mode have basically have the same permissions of this file, which is the source file descriptor, and just we're going to pass it right here. That's it, all right? So let's continue. And here what we need to do, we need just to do a while loop and read from the first file and write to the second file, which is this file descriptor. So here let's say copying data from the first file to the test file. Let's say here source file test file. Alright, so I'm going to do while, and here I need a variable, so let's do int, no, size t and bytes equal to 0. Good. So while this bytes equal to read, so we're going to call the read syscall from the source file descriptor, and we need to save in the buffer, and the size will be, for example, 4069, like this. Alright, does not equal to 0. Alright, like this. So I need to create this buffer where we're going to save data that we are going to read from the source file. Alright, so here we have char on the buffer, as we said, it's gonna be a 4000 and 69, no, 69, like this. All right, good, good. So here who doesn't know the read function, it just read from a file from the file descriptor and save in the buffer, and every time it read, it return how many bytes it reads. So if it doesn't equal to 0, it means it's read data. So when it's equal to 0, it means that there is no like data to read from this file, right? So let's do here bracket, and here also. Good. Then we are going to write to the file descriptor, which is source, which is destination file descriptor, and we are going to write from the buffer size each time 4069, like this. Good. And I need a variable, another variable which called total, which count how many bytes we transferred from the first file into the second file. So total will equal to 0 in the first place. Alright, good. Let's continue. Let's go down here, and total plus equal the bytes, like this. Alright, so let's see. Let's do Control Shift. Let's open the terminal and let's compile to see. I feel there is some errors. Oh, no error. Weird. So we have, for example, let's say touch file 1 and file 2, for example, vim file 1, for example, hello world, and let's save it, clear, and let's run it out, file 1 and file 2. So if we did cut the file 2, it will have a, as we can see, it will have just dump data. Why? This is the question. So here we are reading from this file and saving in the buffer. Yep, and the buffer. Yep. I need to do not for 4069. How many bytes we read to exactly print what is inside the buffer? This is the problem. It's too clear. And gcc main.c. Let's run file1 to the file2. And if we did cut, what? What's the problem, bro? What is the problem with you? Let's remove the file2, for example, and let's do, for example, again gcc main.c, and for example, let's say file3, and let's cut this file3. He didn't create the file3. Why? Where is the problem? Let's print this file descriptor. So let's do print f and percentage d like this. Let's do vcc sorry -1. Why? Because of the mode? No. Yep, as you can see, the problem, it was in front of us. Here I should do like this, not comma, the or operator like this. I don't have nothing to say. Let's run again and let's do file3. As you can see, the file3 have been created successfully and it contained the hello world. Then bro, let's add the I flag -I like this. Do you want to overwrite this file3? Yes, I want to overwrite it. And let's remove this print and let's do cut, for example, file3. Good. Now we're going to implement the verb base, which is the flag-v. Right, so let's do if condition. So if dash v the flag is equal to 1, then we're going to do printf, and the same thing we're going to do %s and this operation, and also %s, and here %d bytes. Alright, and here we're going to do av of index I, and here av of index I +1, and here we're going to do the total like this. And here I need to do some checks. So if the file descriptor is less than 0, we need to do the stfd is less than 0, sorry, less not greater. Then we should do printf. We cannot open this file like this. We cannot open this opening this file. Okay, nope, like this, and %s and av of index I. Good, and return 1. Good. I guess I need to do this also for this source file descriptor. So let's do the same thing here. Where is the open? Yep, here is the open. The same thing. Let's do here source, and here we need to do the I, and here I need to do the I +1, not just the I. because we are talking about the second file. Alright, so here we have reading, and here let's do a comment implementing the v flag. Good. Let's see here, taking the permissions from the source file. Good, good, good. Alright, that's it. Let's run the program and let's see. So let's do C and the cp like this, and let's do, for example, vim file1 and a lot of data. Okay, like this. For example, big data like this, and let's do gcc main.c like this, and let's run it. For example, let's do -i and -v file1 into file3. Do you want to override this file3? Yes. File1 into file3. How many bytes have been transferred from the file1 into the file3? So if we did cut file3, we are going to find this. For example, if we did, for example, let's do the same command for a non-existing file, for example, file4. Do you want to override this file, which is the file4? No, for example, there is no file4. And if we did, for example, yes, it will have the file 4 like this. That's it. So let's add something right here in the question. Alright, good. Let's compile. Okay, for example, file 5. Do you want to overwrite this file and double quotes the file 5? Yes, I want to overwrite it. Cut file 5. Good. For example, if we did wanna, for example, let's do vim file1. Alright, as we can see, if we did the same operation again, we will find the amount of data have been decreased. Right, so this is our implementation of the cp command in C. It's not a full implementation, but I tried my best to do like the same behavior of this command. So that's it. This is our video. I hope you enjoyed, and see you in the next video. Peace.